Hey, it's Tony from Adafruit, and in this video we're going to look at the Charlieplex LED matrix driver and MicroPython. So Charlieplexing is kind of an interesting way to control a lot of LEDs from a few different lines, and you might hear my cat, she's a big fan of Charlieplexing. So hey, this is live internet, anything can happen with pets and fun stuff. But anyways, so Charlieplexing, we'll look at this. It's a way to control a lot of LEDs with just a few lines of digital control. And the nice thing is they're actually driver chips like the IS31, FL3731. That rolls right off the tongue. So that driver chip can control a lot of Charlieplex LEDs and give you a really easy interface so you can connect to it over I2C, send a few commands, and turn on like, probably hundreds of LEDs potentially. But we have these nice little matrix displays that look kind of like this. So you can see this is a grid of pixels. So you can control all these pixels. That's 15 by 7 kind of size pixels there, number of pixels. So you can do pretty cool things with this. Eventually, like scroll text, display graphics. We'll see MicroPython support. It's a little bit basic right now, so you can just turn on pixels and fill the display. But that's the start. That's kind of the basics that you need to do a lot of different graphic stuff. So let's just dive in and get started with this. We'll jump to the main view here. So we'll go to the desktop. And again, of course, there's a guide that goes with this. It's not published yet, so as soon as this video goes up on YouTube, look in the description below and there should be a link to the guide. I'll publish this video once the guide is published, so you can take a look at it. And the guide will just walk through exactly how to wire up the Charlieplex. There's both a feather wing, which is kind of this version up here that you can see in the corner. And this is the little ESP8266 feather. There's the feather wing version, and then there's also a breakout board version of it, and you can kind of see it on the right hand column right here. So this is nice if you're using a different MicroPython board that's maybe not in the feather form factor. You just have to connect the I2C connections, and it's pretty straightforward and easy to get going, and I'll show you in the guide here how to do it. So, okay, let's just kind of dive in. So the guide, the first page just talks a little bit about what it is. Like I mentioned, Charlieplexing, a really interesting way that you can control a lot of LEDs just using a few different digital input lines. So, you see this grid of LEDs and you might think like, okay, there's 15 by 7, so that's like, I don't know, almost like over 100 LEDs or close to 100 LEDs on here. And so do you need 100 digital input lines on your microcontroller to make that work? I mean, that's one way you could do it. But that's going to require a ton of input, and especially the little chips on the feather boards certainly don't have 100 digital inputs. And so that's the cool thing about Charlieplexing, is that it uses a matrix of wires where you connect kind of the positive and negative leads of each LED in a different way. So there's, and I don't fully understand, but I'm pretty sure there's like a column and a row structure, and so you can individually address each of the LEDs on here. And then the cool thing is, like I mentioned, this IS31FL3731 driver chip, it can actually PWM, or pulse width modulate, control the LEDs, which means it can dim the LEDs. So you can see kind of in this little animation here, there's like brighter LEDs and less bright LEDs on here. So it takes care of all that work for you. You just tell this driver chip, turn this pixel or this LED to this intensity of brightness, and it'll do everything for you, which is awesome for this. So, okay, to get started then, check out the hardware page. And this just talks about what you need to follow this guide. Obviously, a board running MicroPython. I'm using the ESP8266 in this example. You can use a Feather M0 with the SAMD21 processor and kind of the experimental firmware. You could use the Pi board, you could use the YPi, pretty much any MicroPython board. There are some small differences in how you initialize the I2C that we'll kind of mention here for it. And then one note for the SAMD21, you probably want to use the latest master branch firmware, which we don't have a release for yet. But I noticed the current release, the 1.8.5 release, has a little bit of instability, or it's a little bit slow. So if you notice weird things, hey, it's experimental. But the ESP1 is working super solidly so far from what I've seen. You also need, obviously, the Charlieplex matrix driver or feather wing. And so I linked to a few different things. Like I said, there's a feather wing version of this, which is actually what you see right here. And that's a 15 by 7 matrix. or there are these standalone, there's the driver board. So you have to get two things basically. You have to get the driver board right here, which I'll show you. And so the driver board is just a standard little board you can connect to. Oh, that's kind of funny, that linked to the wrong thing. Let's try that again. We'll see, hey, live internet. There's sometimes, there we go, it worked this time. There's some kind of a weird bug where if you're logged into the Adafruit site, sometimes it might redirect you once to the wrong spot. So we'll have to track that down later. Anyway, so this is the Charlieplex driver board. So if you're going to use the driver board, you need the driver board and you need to buy one of the LED matrices right here. So it doesn't come with the matrix. So you have to pick which color you want. And these are fixed colors. You don't have RGB matrices. So you've got to pick, like, you know, maybe a blue color, for example. So you get both of these, and then you can solder this onto, just, you know, using some headers, you can solder it directly onto that driver board that you saw right here. So that's easy to do. Or you could put sockets in there, and then if you wanted to swap out different colors, you could do that. The one thing to note though is that the breakout matrix is a little bit larger. It's 9 by 16 instead of 7 by 15 on the feather wing, just because that's as much as you can fit. If you can fit more than 7 by 15 on this feather wing, then more power to you, but that's pretty tightly packed on there. So you get a few more pixels basically on the breakout board if you need those. So okay, so let's go back. And then obviously you might need a breadboard, some jumper wires, some soldering tools, the standard stuff to build a lot of projects. And then obviously when you get your feather wing or your driver board, follow its product page and its guide. Make sure to assemble it. You'll have to solder on the headers and things like that. Test it out with Arduino. That's usually a good kind of first step. Even if you're using MicroPython, good to try it out with Arduino just to make sure you're not troubleshooting two things, because a lot of this MicroPython stuff is pretty new and cutting edge. So, you know, you don't want to be scratching your head and wondering, why doesn't it light up? Is it, you know, the MicroPython code? Is it the board? So use something that's, you know, kind of the reference or the Arduino implementation right now. For wiring, so if you're using the feather, super simple, just plug in the feather. So I'm just going to do that right now on this ESP8266 board. So it just slides right in, and it will automatically use the I2C connections on the feather. So it just hooks up directly like that, super simple. If you're using the breakout, really easy to wire it up. You just have to connect the data, the clock, the ground, and the voltage input lines here. So real standard. There are some other pins on here. This driver chip has an interesting feature. You can feed an audio signal into it, and that can modulate, I think, when it changes the frames. I don't show examples of it here, but it's mentioned in the documentation, and you probably want to look at the data sheet for the chip to understand it a little better. So just some neat stuff though that it can do. Okay, so once you have the hardware set up, then let's jump to the software side here. So we'll plug in this ESP8266 feather, and again, it's running MicroPython, and specifically here, let me see if I can get it, there we go, less glare on it. It's running version 1.8.5, like I mentioned here, of the ESP8266 MicroPython, and you need that version because that's the version that supports these .mpy files on your MicroPython board, because that's basically how we distribute a lot of the drivers now for MicroPython. And so what you need to do is you need to get this driver onto the chip, and so the driver is in this GitHub repository. It's linked to from the guide. I'll put a link in the description when this goes on YouTube. And so look in the releases tab, and you should see a release here, and you want to grab the .mpy file. So I'll copy this, and then let's just download it. So I just have a terminal open here. So I will wget download the file. And then once you download it, you need to get it onto the board. And so for the ESP8266, it doesn't look like a USB drive. So you need to use a tool potentially to copy the file over there. Ampy is a tool that I've used in the past and kind of shown how to use, and I mentioned right here. So there's a little guide that'll show you how to use Ampy if you've never used it before. I have it set up right now, and it's actually, if you use the Ampy _port environment variable, that basically will tell Ampy, here's the serial port connected to my device, so that I can run these Ampy commands and not have to specify the port every time. So if I just run like Ampy ls, this is going to list everything that's on the file system for this board, which you can see there's just the boot.py, so really nothing on that board. But let's do ampy put that is31fl3731.mpy file. So we'll copy this to the root of the board file system. And now when I ampy ls, we should see, yeah, there's the .mpy file. So okay, cool, so we're done. We've got the file copied over, and now let's open up the serial REPL so that we can start to use the module. And it's real simple. If you've seen any of the other videos on some of the displays, real similar process as all the other displays we've used. So let's use the screen command to open up the serial port at 11.5 baud. And again, I mentioned, if you're not familiar with the serial port and the REPL, or if you're not familiar with MicroPython in general, go back to the overview page, and I link to some of the kind of getting started guides, like what is MicroPython, and then also go to this category here in the Learn system, and this lists every MicroPython guide that we have. So we have quite a few so far. It looks like 16 of them. Maybe this will be the 17th one once this is published. So lots of guides, but start there and go through those because it walks through the basics of explaining what it is, what the features are, what the serial REPL is, how to access it. Like on Windows, you probably have to use PuTTY or different tools to do that. So, again, check all that out to find more details. Okay, so we're connected to the REPL. I'll just hit enter so you can see the prompt right there. And then the first thing we need to do is initialize I2C. Because this Featherwing uses the I2C connection, the adapter or the driver board also uses I2C. So to do that, we import the machine module, and then on the ESP8266, you create an instance of the machine class, and you need to pass in the pins. The first one is the clock pin, and for the feathers and Featherwings, the clock pin is 5, and then the data pin, that's pin 4 by default on those boards. So I do that. You don't need to do anything else. You don't have to initialize it. In the SAMD port, kind of right now you have to initialize it, but in the future you won't have to. At that point, we're ready to go with the I2C bus. So now we want to import this IS31FL3731 module. And it has that funky name because that's the name of the chip, basically. So a lot of our modules use that convention. It's kind of the low-level chip that's used for this. So let's import that IS31FL3731 module. Okay, so that's imported. And then there are two classes inside of there. There's a matrix class and a Charliewing class. So the matrix class is what you want to create if you're using the matrix driver breakout. That's the 16:9 LED grid. If you're using the Charliewing like this, the 15:7, you want to use the Charliewing class because they're both built to use kind of different size displays for this. So I'm using the Charliewing, so I'm going to use that class. But just switching between them, they're both exactly the same as far as you need to pass in the I2C interface that you created above. And then if you've changed the I2C address of the device, like I kind of mentioned here, you can, on the breakout board, solder some connections closed to change the address. You can specify that as an optional parameter here. So I mentioned the guide. For mine, I have the default, and for the Featherwing, you probably have the default set also for this. But it's good to know you can have, I think, up to 3 different boards connected. Breakout boards specifically. As long as they each have a unique address, you can have 3 different displays, which could be kind of cool. You could have like, maybe a neat like skull with the 2 of the boards, 1 for each eye, and then you've got like cool little LED animations or something for that. So anyways, let's create an instance of that Charliewing class. And remember, there's tab completion. So, I just typed IS and then tab, and it realized that, oh, I've already imported that module, so I don't have to type out all that funky stuff. And then the Charliewing class, and I'll pass in the I2C bus. And okay, and you saw it kind of flicker a little bit. That's because it initialized, and it goes through and it clears out all the different frames. And I'll talk more about the frames, but it'll start up and clear itself out to kind of a blank display at this point. And okay, so now we're ready to start hacking on this and making it light up and do different things. There's really just basic drawing stuff. Like I said, you can fill the display, like set every pixel. You can set individual pixels, and then you can do a few funny things like blinking, and I'll show you some frame stuff for some potential animation things. But just know, like right now, that we don't have like line drawing and circle drawing and text and stuff like that implemented. It'll come eventually, but it's early days for some of this stuff. So let's just try out the fill command. So fill will basically set every pixel to a value, and so the value you pass in is the intensity that you want to set the pixel to, and that's a value from 0 to 255. And so if you set a value of 0, it turns everything off. If you set a value of 255, it turns everything on to maximum brightness, and then something in between will set the pixels to kind of a proportionally less bright value. So let's do 127. That's kind of half the brightness basically. So I do that, and then notice, boom, the display instantly turns on. So you don't have to do anything like call a show function or something like that. It's basically, you're just directly modifying the pixels that are shown, or the LEDs on the display when you do that. And you might hear there's a little bit of a buzzing sound. It might be coming through on the microphone, and that's normal because this Charlieplex display, it's doing some kind of high frequency stuff where it has to individually turn on and off each of the pixels. It's doing this PWM control, so sometimes you can get some noise from that. So just realize there might be some audible noise, kind of like with EL panels. You know, you have this inverter that's switching at a high frequency, so that can cause noise too. That's why you might hear that. But you can also turn them all off. So if I fill with 0, we go back to all off. Now I'm not going to fill to 255. You might wonder, like, let's turn them on all full bright. I've done this, and you have to be careful because when you turn each of these on, there's like almost 100 LEDs there. Full brightness, they can pull a decent amount of current, and I noticed when I do that, it will actually reset my board after a second or two because it's trying to pull too much power from the USB port that I have this connected to. So it works fine if I connect this to a battery or an external power supply, but over this USB port, I can't fill every LED to 255 or else it resets. And I put a little warning in the guide about that. So just be aware, like, you know, 100 LEDs, that can pull some current. So make sure that your power source is up to that. But, you know, doing like 127 or so seems like it's okay for it. So, okay, so that's easy. You can fill, you can set all the LEDs to a value. And then you probably want to set pixels though, so set individual pixels. And there's a pixel function that you can call here. And so you pass in the X position, the Y position, and then the intensity that you want to set that pixel. So for example, if I say display.pixel00, and this, since it's 1 pixel, I can set it to full brightness. It's not going to hurt anything. So I do that, and hey, there's pixel 00. So that's basically X position, which the X is kind of your horizontal position, and then the Y position, that's your up and down position. So your X position, you have 0 to 14 because there are 15 pixels total, but pixel 0 takes up column, or the first column is value 0 basically. So 0 to 14 on the x-axis and 0 to 6 on the y-axis. So if I want to do this pixel that's right below it, like all the way down on column 6 or y-axis 6, then I just want to say display.pixel column 0, but y-axis row 6 is value 255, and then lights up like that. So pretty simple. I can turn off a pixel, so if I want to go back and say pixel 0, set it to 0, and then you can obviously control the intensity. So if I want to set this one to like maybe 50, so like a less bright, so you can see it's a little less bright than this one up here that's value 255 for that. So that's pretty much it for setting the pixels. You know, you can go and set pixels. You're gonna have to code up your own like line drawing and animation and stuff and circle drawing and stuff. But in the future, we'll probably have a graphics library that lets you do that in a more automated manner. But this is the basics, so you can get started and do stuff like this, like the Game of Life, for example, that Lady Ada did. And I think there was actually a tweet earlier today, or maybe last night, that there might be a Game of Life on the Charlieplex display here. So I might put a link in the description below on YouTube to a video that shows that off. So, you know, even just basic pixel control, you can do fun stuff and make like little games and things with it. And because, you know, you only have 15 by 7 pixels, so you could maybe do a very small Tetris game, you know, in this orientation like that. Although the interface could be challenging. You don't have any buttons on here, so you would need some way to control this device. But I don't know, you could maybe put an accelerometer on here somehow, and you know, maybe you tilt it to move the Tetris pieces around or something like that. That'd be kind of fun to do. But anyways, that's a maybe future project to look at. So, okay, there are a few more things I wanted to show with this display. So there are some neat features. You can actually blink pixels on the display. And so there are a couple ways to do this. So first, let me clear the display. I'll fill everything with a 0 value. And then there are two things you do. So you can set the blink rate, and that's how quickly the pixels blink in milliseconds. And so you call this display.blink function, and you pass in the rate in milliseconds. So if I want to blink every 500 milliseconds, which is like every half second, I can pass that in. But realize this driver chip, I think it only blinks at a resolution of 270 milliseconds. So it's just going to kind of make a best effort at trying to blink at whatever rate you specify. You know, ideally you probably want to specify a multiple of 270 instead of something like 500, but it'll just try to get as close as it can to that. Okay, so I did that, but notice nothing happens because that's just setting the blink rate. Each of the individual pixels has both an intensity and a flag that says whether it's blinking or not. And so you need to individually say for each pixel which one you want to be blinking. And you can actually use the fill command to set all of the pixels to blink. So if I do display.fill with a color of 127 basically, or half intensity, and then I can say blink equals true. And so blink is an optional keyword argument here, and this will go through and set every pixel and say, okay, you should be blinking. And every pixel, you can't control the blink rate individually. They just have a global blink rate for this. But when I do that, notice, hey, it's blinking pretty quickly, about maybe once every half second or so. And if I want, I can change that blink rate to, like, let's say maybe 1,000. So it slows it down a little bit, so you can see it's blinking at a different rate like that. So that's kind of cool. And if you want to turn off blinking, you just set blink to false on all of these. So, it goes to false. And then maybe I'll clear the display again. So we'll say display fill 0. And then if I want to set an individual pixel to blink, you can also do that with the pixel function. So if I say pixel 00, 255, blink equals true, then we'll see you got a blinking pixel. So that's kind of cool. You could do some neat effects with that potentially. And it's nice in that the driver chip is taking control of all that blinking logic. So your microcontroller doesn't have to worry about, like, should I turn it on? Should I turn it off? How much time has elapsed or whatever? It's all just done in the driver. But again, you don't have as much control. You can't say pixel by pixel, what the blink rate would be potentially. So, okay, that's the basics of blinking. And you can turn it off, obviously, too, by just setting blink equals false for that. So that's kind of cool. And the last thing I'll show is that this driver has a concept of a frame. So there are 8 frames, and each of those 8 frames is basically like an entire display memory. So it can remember how each pixel was turned on or off, and even if it was blinking or not. It can store that into a frame, and then you can switch between the frames by just calling a function. And so this is good if you had like a few different frames of animation and you wanted to, smoothly animate between them. You can just swap the frames instead of having to redraw the animation every time. So it's kind of nice to have that option to do that. And so, or like you don't have to use it for animation. I mean, you could just use it as an extra buffer of memory to, throw some pixel data into, like to do double buffered animations, for example, if you're making a game or something like that. But I'll show you how to use it. So there's a frame function, and oh, here comes the cat. So she's got inspected. She's probably gonna sit there. There you go. So that's the best way to trap a cat is to put a towel down. For some reason, she loves sitting on the towel. So anyways, the cat will join us to check out how frames work. So to use the frames, basically when the display starts up, it will use frame 0. And so whenever you're dealing with setting pixels or using the fill command, it's going to be doing that against frame 0 and displaying frame 0 at the same time. But I can switch to a different frame. So let's switch to display.frame. Let's switch to frame 1. So the first parameter to the frame function is which frame you want to switch to. There are 8 frames, 0 through 7, that you can use. And then there's a show parameter which defaults to true, but I'm actually going to say show equals false. And that means switch to frame 1, but don't actually display it. Keep showing the previous frame, which is frame 0. But what's happened now, anytime I use a drawing command like fill or pixel, it's going to apply that to frame 1 and not the currently visible frame 0. So if I do display.fill 127, nothing happened because I changed frame 1, which is not visible right now. But if I want to make frame 1 visible, I can say display.frame and use 1, and I can say show equals true, or it actually defaults to that. So if I don't specify show, it's just going to automatically assume that I want to switch to that and show it. So when I do that, hey look, everything just turned on. And that's because, in the previous command, I changed frame 1 to be filled with that 127 kind of half intensity, and then I switched to show it. And I can go back and say, let's display frame 0, and we go back and we get that 1 pixel lit, which is what we had on frame 0 again. And now if I do drawing commands, they're going to draw against frame 0. So if I say display.fill 0, that's going to draw against frame 0, but then if I switch back to display.frame 1, it's fully lit again because, you know, I didn't change frame 1, I changed frame 0 before. So that's just kind of a cool, handy thing to be aware of with this module, that you have that ability to store up to 8 different frames of animation and then just swap between them with the frame command here. So, you know, you could maybe pre-generate some images and then have like a loop that waits a little bit of time and then switches between them potentially. So lots of cool options that you can do with that. There are a few other small features that I'm not going to mention in the guide or the video, but check out the documentation that links to it here. So you can do things like fade between frames. Although I noticed when you call this, it defaults to a pause value of 0, and it's doing some math in the library where that fails. So there's a bug in the library which we'll fix eventually. So the fade function may or may not work super well for you. You can control that audio input pin where if you feed audio into it, it can go through different frames of animation for it. So something interesting to try out and maybe play with and do a future project with for this. So, you know, just a few extra things that I'll mention there. But otherwise, that's it. So that's how you use the Charlieplex Featherwing and Breakout. So both of these give you a nice, really cool grid of pixels that you can get individual LED pixel control over, and not just on and off. You can also control, you know, 255 levels of brightness. So you can have bright pixels, less bright pixels, do really cool like fading and stuff like that with this. So awesome display. And because they're these bright LEDs, you know, it's really nice and easy to read. And eventually we'll get some nice graphics libraries. So, you know, I can imagine in the future, this will be perfect for like scrolling a message across, you know, a text scroller or something like that. So look forward to some of that stuff in the future. Okay, if anyone has questions, throw them in the chat. But yeah, I don't think I see a ton of questions. And yeah, luckily this was a fast, quick little video. A lot of these displays are all real similar. So the guides for these are starting to turn into kind of cut and paste in some ways, which is good. It's all, you know, very similar interfaces. So let's jump back to the main view and we'll go here. And apologies, I think the video still stutters a little bit. I'm still playing around with CPU usage stuff, so having some issues with that. But anyways, check out youtube.com/Adafruit. You can see this video, all kinds of other fun project videos there. Check out twitch.tv/Adafruit. That's where I stream things live. I like to do at least a couple streams per week, one on Tuesdays and one on Wednesdays. You might be wondering, where is the Tuesday stream? Well, it was actually a stream last night. I did one late last night, which I'm going to publish on YouTube pretty soon. So keep your eyes peeled, subscribe on Twitch, and you'll know whenever we're streaming. And then you might be wondering, why am I doing the Friday stream on Wednesday? That's because I'll actually be gone Friday, so I'll be out in Pasadena for the Hackaday Super Conference. So if you're out there, you know, maybe come and say hi to me. But anyway, so I still wanted to get a couple guides out this week, and so that's why we've got them here. And like I said, there's a Learn guide that goes with this, not published yet, but once this video is on YouTube, look in the description below and you'll see a link to that because I'll put it up once it's published. So otherwise, until next time, this is Tony from Adafruit. You know, make sure to like, comment, subscribe, let us know that this is interesting info, that people get good stuff from it, and we'll keep doing all kinds of content like this. So until next time, Tony from Adafruit, thanks for watching. See ya.